Hello, welcome to this quick exam question walkthrough on an organic synthesis and spectroscopic analysis combined question. So I'll take it sort of one stage at a time for the question. It says L, M, N, and P are straight chain organic compounds containing carbon, hydrogen, and oxygen only. So looking at the flow chart, the first thing that comes to mind for me is it's likely to be a primary alcohol because you're refluxing it with acidified potassium dichromate to make a dicarboxylic acid. Now, dicarboxylic acid means it's got two COOH groups, so they'll be at both ends. So the thing to think about is whether L has two alcohol groups. Now, before we decide on that, we might have to look a bit closer at the molecule and some of its information. So if you eliminate H2O from a primary alcohol, you're going to end up with an alkene with a CC double bond at one end. So that's what N is likely to be. So taking the percentage composition by mass, we can work out that the empirical formula is CH2O. But CH2O doesn't add up to 90, it adds up to 30. So the molecular formula is C3H6O3. So I've had to use the relative molecular mass of 90.0. Now it says the infrared spectrum is on the next page. So let's have a look at that. So they've asked us to put in the answer space our workings using the information on the previous slide to calculate the empirical and molecular formulae. So we pop all that down there first, and now have a quick look using the infrared information from the data sheet. You can see that you've got an OH peak from carboxylic acid and a C double bond O. So those two together would suggest strongly there's a carboxylic acid functional group in L. So coming back to our flowchart, we know already that its percentage by mass data gives us C3H6O3, and the IR spectrum suggests a carboxylic acid functional group. So we can deduce that it's got one COOH group already and one OH. So that would suggest this compound here. Now that would mean that the primary alcohol would oxidize to form another carboxylic acid group on the left-hand side, leaving the other carboxylic acid group on the right-hand side in place. So the equation they're looking for the reaction of L to form M is the full oxidation of the primary alcohol part of L. So you need two O's in square brackets and you produce an H2O. So the final part is determining the structures of compounds N and P. So if we go back to our flowchart and put in the structure for L that we worked out. If you're going to eliminate a water molecule, it's going to come from the side that has the primary alcohol, which I've highlighted in yellow. So that means that the carbon-carbon double bond appears at that end of the molecule. Now the MR for that particular compound is 72 grams per mole, and they tell us that the MR for the polymer is 10,000. So to get the number of repeat units, you divide 10,000 by 72, which gives you 139. And finally, you can put in the equation that forms polymer P. So you start with your alkene structure there. So this is this compound here, but drawn out in partially displayed form. N is going to be the number of individual monomer units, and therefore that's where the N goes over here outside the square brackets. Okay, hopefully it's been a useful quick whiz through this question. Thanks as always for listening. Until next time, see you soon.